Hello everyone and welcome to Mathematics, where this channel is able to help you to build up your habit in completing a question a day in mathematics. So for today's video, we will look at a question from Form 5 Chapter 1 Circular Measure. So before we begin, y'all can try it out by yourself first. So what we see here is we have three cylindrical containers and they are being held by a elastic band. So now what you see now is the front view of the cylinders. So you can see now there are three circles and outside it there's a band. So what we can highlight from this question is for each of the circle there is a radius 3 cm, which is the only info that we can get in this question. And if you look at question 8, it tells us to find the shaded area. So for the shaded area, what we do is to find the bigger shape minus out the unimportant smaller shapes. So now even the big shape we couldn't identify. So what we do is we can connect all the circles radiuses together to form a shape. And using the triangle as our big shape, and we minus out these unimportant parts. So these parts are actually sectors. So to find the info for this triangle, what we see here is the sides is 6 cm because they are made up by two radiuses. So 3, 3, 6. And for each of the sides, they are also the same length. So naturally, their angles would be the same as well, which is 180 divided by 3, which is 60. So to find this triangle's area, we can use a formula from Form 4 Chapter 9, which is the AB 1 over 2 AB sine C. So 1 over 2, so using these two lengths and using the angle between them, we can find our area. And to find the area of the sector, which is 1 over 2 r squared theta. So 1 over 2 r squared, we can use the clue, which is 3. And for theta, which is here, is actually the same as this angle, which is 60. So as we know, 60, if converted to radian form, it will be pi over 3. And by calculating this, you will get 1.449 cm squared. So moving to part B, we are trying to find the band's length. So here, what we can see is the band have straight lines here, but they have curved lines here. So we split this big problem into two parts. One is the straight line and one is the curved line. Okay? So if you focus on the straight line, what we can do is we can use the radius that we form in part A to form a rectangle. So why we are doing this is because we can use this way to find the length for this part first, which is 6 cm. So same goes to the other two sides. So here we can write 3 times 6 first. And then for the curved part, which is here, this is actually our arc. And we can use S equals to r theta formula to help us find the value. So for r, we know is 3 because the circle's radius is 3. And for theta, which is here, it is not hard to find it because we know here is 60. And here is a rectangle, so here will be 90 and 90. So here, if I want to calculate the theta out, it will be 360 minus out the 3 parts. And then you can convert it into radian. So it would be 2 over 3 pi. So now we can multiply 3 times r theta. And you will get 36.852 cm. And with that, we have completed this question. So the take home point for this video is split the big problems into smaller parts. So for part B, to find the length of the band, we split the problem into two parts. One is to find the straight line, and one is to find the arc. So if you are interested in this questions answer scheme, you can click the link in the video description, and you feel this is beneficial to you, please give a like, subscribe and share it to your friends and classmates. So I'll see you all very soon in the next video. Thank you.